Hey everyone, in today's video we'll be solving this problem. So if x1 through x9 is an arrangement of the numbers 1 through 9 around a circle, what is the probability that this sum of absolute differences is minimized? And we also take that the x10 is x1 just to make this notation a little simpler. And so have a think about it and I'll be right back with the answer. Okay, so here's what we're trying to minimize, and before we get started with the problem, let's try some examples just to see what this really means. So if we have our circle right here, and let's put the numbers, let's try to just put them in increasing order. So 4, 5, 6, 7, 8, 9. All right, so in this case, we can calculate the absolute differences between each of these numbers and then just add them together. So right here would be 1, 1, 1, 1. We just actually have ones all around the circle, except for this last one where the absolute difference is 8. So we'll put 8 here. And then adding them up together, we have 1, 2, 3, 4, 5, 6, 7, 8, plus 8, that's 16. So for this arrangement, this sum of absolute differences is 16. All right, let's do a second example just to illustrate another point. We can have our circle here, and then we'll take the numbers 1, skip 2, and have 3, 4, 5, 6, 7, 8, 9, and then put 2 on the other side of 1. And so let's try to calculate this sum of absolute differences for this arrangement too. We have 2 right here, then 1's around the circle. Here we have 7, and then 1 again here. And so if we calculate this, it's 2, 3, 4, 5, 6, 7, 8, plus 7, that's 15, plus 1, that's 18, or sorry, 16. So again, we have 16. 16. All right, so you see that by putting the 2 on the other side of the 1, the sum didn't really change. It's still 16. So it seems that 16 is the lowest we can get, and this is actually true. But let's try to prove it using a little bit more rigorous logic. All right, so we want to show that this sum of absolute differences is bounded below by 16. And so we'll make 2 assumptions before we start. First, if you have a circle with, all the numbers arranged in a circle, wherever the 1 is, we can always rotate this disk so that the 1 is at the top, which means that we can assume that x1 is 1. Like without loss of generality, we can just assume that. The second thing we'll say is that xk is 9. Xk is equal to 9, where k is just a number between 1 and 9. This will help us with our proof. And so the first thing we'll do is we'll split up this sum into the sum until xk and then the sum after xk. So this sum from I is equal to 1 to 9 of xi plus 1 minus xi. We'll split it up into the sum from I is equal to 1 to k minus 1 of xi plus 1 minus x1, or sorry, xi, and then plus the sum from I is equal to k to 9 of the same thing, xi plus 1 minus xi. All right, now let's use the triangle inequality to take these absolute values outside of the sum. So by the triangle inequality, this is greater than or equal to the absolute value of the sum from I is equal to 1 to k minus 1 of xi plus 1 minus xi. And same thing here. We can take the absolute values outside. I is equal to k to 9 of xi plus 1 minus xi. All right. Now, what is this term? Well, you'll see that, this is x. For the first term, we get x2 minus x1, and then x3 minus x2, x4 minus x3, and so on. And so you see that all the x2s, x3s cancel out, except for the last one, xk and x1. So this is actually equal to xk minus x1, since all the other terms cancel out. Same thing for here. This is plus, and then the last term here in the sequence is x10, which is x1. So actually, yeah, we can just write x10 minus xk. But we know that x10 is x1, which is 1. So here xk is 9 and x1 is 1. So this is equal to 9 minus 1. And then right here, x10 is x1. So this is 1 minus 9. And so this is 8 plus 8, which is 16. So we've bounded this sequence below by 16, which is exactly what we wanted to show. Okay, so now we want to find all arrangements possible that add up to 16 here. And so yeah, the one we got is where we just put all the numbers in increasing order, and the 9 to 1 was 8, and then all the others was 1, so the sum was 16. But what are the other possibilities or the other arrangements that lead us to 16? Well, you can remember that if we put the 2 on the other side of the circle, the sum stayed the same. And we can actually, if we have a circle here, and one, we'll put 1 at the top because we can always rotate it. And then wherever we put 9, we can actually put the 2s, the 3s, the 4s, or yeah, all the other numbers on either the left-hand side or the right-hand side, but they only have one place to go on each side. This is because, let's say I put the number 2 here, and then I put the number 4 here. Well, if I switch these two numbers, like the absolute differences here would be 3 and then 2 here. If I just switch the 2 and the 4 and leave everything the same, this will actually decrease this sum. This will be 2, or sorry, this would be 1, and then this would be 2. So this sum of absolute differences, since it's smaller here, it'll be smaller around the whole circle. So actually, this from 1 to 9, all the numbers have to be increasing, and from 9 to 1, all the numbers have to be decreasing. And so even though we can put the 2s, the 3s on both sides of the circle, they can only go in one place on both sides of the circle. And so since there are 7 numbers left, 2, 3, 4, 5, 6, 7, 8, and we can only put them in one place on each side of the circle, we actually have 2 to the 7 arrangements of these numbers around the circle, such that the sum is 16. And so now we have to figure out how many total arrangements are possible around the circle. You might think that it's 9 factorial since there's 9 numbers and we can put each number wherever. But that's actually not true because the 1 is at the top, and the way we set it up, we always have 1 at the top. So 1 is actually, it's not free, it's fixed. And so the correct answer is 8 factorial. There are 8 factorial total arrangements since we can choose any of the other 8 variables freely except for 1. All right, so now if you want to evaluate this, this is actually just 128 divided by 40,320, which is 1 over 315. So the probability that we actually get the sum of 16 is 1 over 315 for any arrangement of the numbers around the circle. All right, I hope you enjoyed that problem. If you did, please consider subscribing, and I'll see you next time.